This is Dr. Ganga Saimina, and right now I'm speaking from Haryana. There is an institute known as National Dairy Research Institute. It is located in Karnal. So basically, I am a senior scientist in the field of dairy processing or dairy technology. So I may not be covering much about food processing equipments, but as the topic is very common, which is applicable on dairy and food in the similar lines. So I'm dealing with the general aspect of the CIP. Is that fine? Can somebody will respond to me that am I audible or not to you?
So you're audible. You can start your presentation. If you have ask any questions, they can write in the chat box also, sir.
Okay, no issues. Then fine.
No issues, sir. Yes, sir.
Okay. So the outline of this presentation includes introduction about cleaning, why it is necessary, which are the different agents, and which are the different methods that are used, followed by sanitation. Again, what is the requirement, why it is necessary, and which are the most common dairy sanitizers or food sanitizers, we rather than say, and followed by hygiene, control, and conclusion. Okay. So coming towards the introduction, uh, you know, my slides are mostly focusing on dairy, but milk being a very perishable component, we can see that if we can deal with the milk, so we can deal with other food products easily. So we know that until unless this is inside the udder of the healthy animal, or if we talk like milk is something which is naturally secreted and from or we got it from the healthy animals, and it normally get contaminated when it come into the contact of the environment, or it may be the milking person or the utensils. Okay, so contamination in dairy of food processing starts during production, collection, conveying, processing, and storage from plant personnel, even maybe machinery, or it may be the packaging material. Okay, so nowadays uh, there is a right of consumers. Earlier, what happens that the demand supply curve was differently working. Earlier, demand was high and supply was lesser. So even subgrade materials can be sold out. But now the consumers are very much aware, and that's why if they are paying money, so providing them with the safe food products is their right, and that can only be produced through the applicability and maintenance of the efficient cleaning, sanitation, and hygiene practices. So here we can see like it's very we can understand this concept with the easy example of the clothes which we wear. We can buy a set of very costly shirt. uh, we can pay a lot of amount to buy a shirt, but if you are not cleaning it properly, after a few days it will like create problems. So it doesn't matter what kind of shirt you are buying, what kind of stuff you are getting, how much money you are paying for that, but the cleaning is necessary to wear it again. The same thing apply in our food processing as well. Like cleaning is necessary irrespective of the brand or the type of the equipment which we are using. It may be supplied by a local supplier, or it may be supplied by an international supplier, but cleaning is an internal part. Okay, so these are some of the equipments pictures which I have. You can have an image in your brain that n number of equipments could be there which are used during the food processing, and there the all the equipments need to be cleaned properly uh, with respect to whenever we are using them. Okay, so basically coming to the cleaning, what is cleaning? So cleaning is the process in which complete removal of food soil. What is this food soil here? It is the unwanted matter on food contact surface. Is accomplished using appropriate detergent chemicals under recommended conditions from the internal and external surface of the equipment. Okay, just a second. Oh, I did some mistake. Am I audible? Hello?
Yes, sir. Yes, sir. You're audible, sir.
Just a second. I was about to select a marker and I missed my screen.
No, sir. Your screen is visible totally.
This is visible to you, but not to me.
Okay.
So from where I should get it back?
So you can reshare your screen if you can't able to see.
Okay. Just a second. Is it visible?
Yes, sir. But sir, your PPT is not visible. Okay, fine. You have to reshare your screen, sir.
I need to reshare my screen. That's what I want to do. Is it okay? Just a second. Give me a second, please. I think
You have to share your PPT to the Chrome browser.
just a second. Just a second. Give me a second, please.
Yes, sir. Yes.
I think there are two screens. That's why problem is there. Is it okay now?
Yes, sir. Now it is okay, sir. Cleaning slide is there.
Yeah, cleaning slide is there, but maybe I need to look at different side. Just a second. Just a second. Does my camera angle is correct? Now?
Yes, sir. Yeah. Sir. Sir, angle is
Just
correct only.
clear was correct, but it is okay. Give me a second, please. It will be good for
Yes,
me
sir.
now. Okay, so I was telling about this cleaning, that is the process in which we are removing unwanted soil from the food surface or food the this equipment surface, and it is accomplished using appropriate detergent chemical under recommended conditions from the internal and external surface of the equipment. So if we go further, now slides is not moving. Some problem is there. I have to rejoin. I have to stop this sharing.
Sir, no, you can put normal. You can do. Don't put on a slideshow mode. Just normally you can show your PPT.
No, that's okay. Give me a second, please.
Yes, sir.
This won't work in that sense. So what I'm sharing right now, screen one. Is it visible?
Yes, sir. It
Is
is
it visible
visible.
now?
Yes, sir.
Clearly?
Yes, sir. Yes, sir.
Hey, if it is visible, then fine, no issues. If it is okay now. Okay. This is visible. Okay. So some of the like precipitates remain intact to the equipment surface after cleaning and form a film over the equipment surface that is known as water stone, which is normally white or grayish film. And heat denaturation of protein present on the equipment surface or absorbed by the other components from milk stones quickly over heated surfaces. Okay, so basically these soils can be divided into two types. Well, the first one is the water soluble, which contains sugar, starch, and salt easily cleaned by the water. And another one is the water insoluble, which is further divided in organic and inorganic material soils. So here you can see, like these are the example of inorganic soil. Soil subclasses includes hard water deposits, metallic deposits, alkaline deposits, while these are the examples like calcium, magnesium carbonates, common rust and other oxides. And organic soil consists food deposits. It could be the deposit of petroleum deposits or non-petroleum deposits, which is like food residues. And in petroleum deposits, we include lubrication oils, grease, and other lubrication products, or maybe animal fat and vegetable fat products. Okay. So the source, which could be the source, different sources of this soil. So first source is the food product which we are handling, processing. Another source will be the minerals from the water residues, and then there will be residues from cleaning compounds. Okay. So very widely in composition and solubility properties. Single detergent not capable of removing different types of soils. That's why we use combination. This is the example of milk stone. Like this is the accumulation of dried milk solids and salts from hot water and cleaning solution. And this is the precipitated or coagulated milk protein and calcium. Calcium. Just a second. Let me take a example. Yeah, calcium phosphate. So here you can see what is the composition of this. If you see here, the moisture content is ranging between 2.68 to 8.75%. It means the TS content of this is beyond 90%. That's why it is known as milk stone. And fat content vary between 3.68 to 17.66, while protein is containing varying between 4.4 to 43%. And ash content you can see here, this is very high. It may range up to 67%. Okay. So there is another term that is known as biofilm, which is the organism attached to the surface with the nutrient deposits. They grow and multiply, and they entrap and this organic or inorganic debris, nutrients, and other organisms. And they result basically in the frictional resistance to flow, and they are creating a problem towards the heat flow across the surface. So these are the properties of various food soils. Like we have different type of deposits: sugar, fat, protein, starch, and monovalent and polyvalent salts. And here you can see their solubility. Like sugar is water soluble, fat is alkali soluble, protein is alkali soluble. Likewise, and how easily they can be removed. So you can see sugar can be removed easily. Fat is very difficult. Then protein is very difficult. So this is like when we are dealing with cleaning without application of any heat. But during processing, we are certainly applying heat in certain applications. So heat-induced reactions takes place in these ingredients. Like in sugar, the caramelization will take place. In fat, polymerization. In protein, denaturation will take place. And interaction with the other constituents will also take place. So it becomes difficult when we are like cleaning the equipment surface post process, and we are not using a single ingredient, so we are using multiple ingredients in a food system, so they will also interact with each other, and then their removal will be challenging. So while cleaning, if we see, so proper cleaning of dairy equipment reduces the chances of the product contamination at each step by reducing the high initial load of a microorganism through removal of their available nutrients. So basic function is to remove the nutrients which are present or available for the microorganisms. So if they don't have feed, they won't survive so fastly. And it also promotes clean and tidy environment that improves operators' moral confidence and helps to maintain safe workplace, creates cleaner production area, and avoid accidents. This also increases the life of equipment by increasing the plant efficiency, improves processing economy, and thus profit to the organization. So indirectly, this is a very important thing, cleaning. Otherwise, a lot of losses, contaminations, and that is result into unnecessary expenses. So let's understand this with the help of certain examples. Uh, this could be like pasteurizer heat exchanger surface, and through which we are sending hot water from one side and like other working solution from the other side. Okay, so when the plant is started in a particular time, so over the period of time, scaling formation will take place over the surface of this heat exchanger, and because of that, the heat transfer through this heat exchanger or from this SS plate will decrease. Okay, so it becomes certainly necessary to clean it after 8 hours or after a shift. Otherwise, what will happen? We can further increase the temperature, but we need to put more energy. Like we have to set the high degree hot water or water at a higher temperature, then only we will get the desired delta T. So this will result in the cost of processing cost. Similarly, there is another example which is known as separator. You know that for the defatting or for the removal of the fat from milk or some other substances, we are using a centrifugal machine, centrifugal separator. And when we are dealing with this, the centrifugal force is working over it. And during this, a scale formation will be taking place. A sludge formation will take place inside the separator. And you know the separation is based on the centrifugal force. So effective radius earlier when the equipment was cleaned, it was higher. But when the sludge formation takes place inside the separator, the effective radius is decreasing. And due to decrease in the radius, less centrifugal force will be applicable. And if we don't clean it, what will happen ultimately? It will result into loss of the fat in your product. So that's how a same equipment may behave differently in absence of cleaning. So which are the different cleaning agents? So cleaning agents are mixture of several chemical compounds employed for a particular function to perform, like washing of floor and walls using the cleaning modes. Different cleaning could be manual, clean out of place, and CIP. So mainly used to reduce surface tension of the water that results in dislodging and loosening of soil, followed by flushing away of the suspended soil particles. And classified as strong, heavy duty, and mild alkaline and acid, employed for a particular use. So we can see here, like usually fat, oil, grease, and proteins can be removed with the alkaline cleaners at a pH more than 11. While the sodium hydroxide, this is known as caustic soda, most commonly used. Potassium hydroxide, this is caustic potash. These are strong alkali uh, cleaners, okay, and that's why they are very corrosive and they will damage the tissue. So it is necessary to understand this. Like whenever we are making a solution out of them, never add these caustic or sodium hydroxide in hot water. Always mix them in cold water. You know the isothermic reactions will take place, and even in plant accidents happen. If you are pouring this directly into the hot water, it will splash and it will invite the accidents. So always keep in mind whenever you are making a solution of alkali, please add this in tap water or cold water. Okay. There are sodium bicarbonate, which is mild, sodium silicates, and TSP would be one of them. If you see further, acid-base cleaning agents are the blend of phosphoric, nitric, sulfuric, and sulfuric acids, which are used to remove encrusted the surface material, which are having a hardened crust as a covering, and dissolve mineral and scale deposits. So in strong, we are having hydrochloric acid, sulfuric, phosphoric acid, and in case of mild, we are having this acetic, gluconic, and levinic acid. So we are using these acid and alkali for the cleaning. Now, if we talk about the basics of the cleaning, so cleaning is reversible of the soiling and requires supply of energy usually in the form of mechanical or chemical action. So you can see over here, like we are having this cleaning object and impurities are bind with this, and these are the forces which are keeping it intact, binded with the surface. So we have to provide extra, opposite, and higher forces as compared to these forces which are binding this impurities over the surface, then only this can be removed. To overcome the forces binding the soil to the soil, both mechanical and chemical effect must be provided by the cleaning system. Okay. So how we express the cleaning? So degree of cleaning results are expressed in terms of physical cleaning, which is the removal of all the visible dirt from the cleaned surface. Okay. And chemical cleaning, removal of both visible and microscopic residues not detected by the naked eyes, but by taste or smell only. We cannot see it, but yeah, you can feel it for your senses. Okay. Then bacteriological cleanliness attended by disinfection, and this is the sterile cleanliness, which is the destruction of all the microorganisms present from external or internal surface of the equipment. So these are the mechanism of cleaning. Cleaning consists mechanism consists of wetting. Wetting means bringing the cleaning solution into intimate contact with the soil to be removed, and for this solution should have adequate wetting and penetrating properties. The next step is displacement of the this residue from this surface of the equipment. Okay, so this soil will be dispersed. The soil will be displaced from the surface by emulsification, saponification, or by the mechanical action, and then it should get dispersed, dispersed into the water, removed from the surface in cleaning solution by dispersion and deflocculation, and finally rinsing to prevent the redeposition of the dispersed soil on the cleaned surface. Okay. So action of blended detergent could be different. Like you can see over here, this is our equipment surface, and you can see like fat is binded in this, and there will be some proteins, yellow color, and there will be calcium phosphates. So several constituents could be a part of this, which is sticking to this equipment surface. So when we are rinsing with water, what will happen? The water just runs off without wetting the surface. The fat present in the soil prevents contact, and the hot water achieves somewhat better result by melting the fat. Okay. So when we are sending some cleaning solution over this surface, so what will happen? To obtain better contact, detergent solution and the film of the dirt, it's to be necessary to add a wetting agent like surfactant to lower down the surface tension of the liquid. Okay, so this will achieve some better results. And then when we are applying this alkaline detergent, the water dissolve the proteins. Okay, so we are having water with the alkali at higher temperatures. So likewise, these proteins will be getting dissolved from this surface, and it is coming into the water. So continuous protein phase, somewhat when it is absorbed water, alkali reinforces the swelling and dissolve the protein and release the other constituents. Likewise, we are able to remove the fat, and we can use chelating agents which will binding a particular constituents. So deposits of calcium salt on the surface are loosened and collected by the chelating agent in the detergent. Okay, and the residual film is now easily flushed away by the water. So these are some of the common steps which are normally used during cleaning. Okay. Now, properties of dairy detergents. An effective and fast acting detergent should have ability to dislodge the dirt from the equipment surface, high wetting effect to enable the detergent to penetrate the dirt deposit, ability to break up the deposits and keep the dispersed, and they are no redeposited. Okay, and then it should have ability to dissolve the calcium salt deposit from the equipment surface, and it must also be able to hold the calcium salts in solution so that the scale deposits are left after the cleaning. Okay, and moderate to low foam generation capacity, and it should be non-corrosive. Okay, so you can see these are some of the common properties we should have in all the detergents. If we go further, uh, so far we are talking about chemical detergents, but nowadays these bio detergents are the like we are using in place of them. If we talk about the environmental protection, so these are alternative to synthetic detergents. These are fast emerging, low toxicity, non-corrosive, environmental friendly, and enhances cleaning properties. So these are the examples like enzyme-based detergents. So we have a substrate, and these enzymes are very specific to the substrate. So here, based on the substrate, we are having different type of these enzyme detergents. So for protein and polypeptide, we are having protease. For mono, di, and triglycerides, we are having lipase. For amylose and amylopectin, we are having amylase. And for cellulose, we are having cellulase. And these are the cellulose. These are the reactions which are happening for the breakdown of these constituents for the purpose of cleaning. Okay. So these are some of the branded detergents like protease. You can find a lot of them. Lipases. These are the suppliers. Amylase. Okay. So we can get this from a market nowadays. Now cleaning cycle. How we are performing this cleaning cycle. So these are some of the basic steps which are performed. The first step is recovery of the product residue through flushing, scraping, or blowing. And the purpose is minimize product loss, reduce load on the sewage system, saving in the sewage treatment cost. Next step is the pre-rinse with the warm water, which removes visible soil, melt felts, and prevent protein adherence and prevent thermal shock to the equipment. Third one is wash with the detergents, so it removes remaining soil, chemical lift biofilm that bind to the equipment surfaces. And fourth one is the post rinse, which removes suspended soils and chemical residues, prepare surface for the sanitation. And last step of the cycle is the sanitation, which kills the bacteria that remains on the equipment surface much efficient time. Okay. Now cleaning methods if we talk. So first of all, the mechanical cleaning often referred to as a clean in place, requires no disassembly or partial disassembly, choice of the modern automatic plant. Another one is the clean out of place, which is can be partially done, specialized COP pressure tanks. And third one, so requires total disassembly. What is going on? Earlier, this manual cleaning was the choice. A lot of equipment has to be dismantled completely before cleaning. But nowadays, we are most of the plant are working on the automatic automation, and in automation programs are there, and they are performing this clean in place. Like they are not opening any of the product, any of the equipment. They are not doing this, disassembling the equipment. Only different solutions are sent through a program which is already written for a particular time at a particular temperature. That's how they are cleaning the equipment. Okay. So suppose if you are having a pasteurizer and how it is cleaned. Suppose it has been just completed the 8 hours to cleaning it. So what do we do? First step is the rinsing with warm water for about 10 minutes, followed by circulation of alkali detergent at 75 degrees centigrade. Priya, am I audible? Everything is fine? Hello? Can
Sir,
somebody please
yes,
tell
sir,
me?
yes, sir. Yes, sir, you're audible, sir.
I proceed?
Yes, sir, you can proceed.
Okay. So basically, if we see this cleaning in totality, so we have three, four important parameters. So first one is the chemical, or in particularly the strength of the chemical. Suppose if you are using this alkali solution, so it must be added in water in the proper concentration. Suppose for pasteurizer it is ranging 0.5 to 1.5%. So like 1% is the average. So first thing is the chemical, right? Type of chemical at a particular desired concentration. Another thing, the temperature of the cleaning solution. So what I mean to say, suppose if you are sending this alkaline water at 20 degrees centigrade, the cleaning won't be efficient. It won't happen at all. Okay. So the right temperature, suppose here it's 75 degrees centigrade. So you have to maintain 75 degrees centigrade temperature. Third thing is the time, the duration of time for which this chemical is in intimate contact with the equipment surface. Okay, so chemical, its concentration, time, temperature, and the degree of turbulence, that is also necessary because that is providing the required forces. So these four parameters has to be maintained properly during cleaning of any of the equipment. If you are deviating from any of these parameters, your cleaning will be compromised. It won't be efficient as we are looking for. So suppose here, but we are doing 1%, this alkali detergent solution will be sent for 30 minutes at 75 degrees centigrade. It will be rinsing out alkaline. It will be followed by rinsing out alkaline detergent with the warm water for about 5 minutes. Then circulation of nitric acid solution around 0.75% at about 20 minutes at 70 degrees centigrade. So alkali was at higher temperature, longer duration, while acid cleaning is at lower temperature, relatively lower temperature, and for a relatively shorter duration. And then post rinsing with the cold water and gradual cooling with cold water for about 8 minutes. And then it comes to the last step where what we are doing, we are going for the disinfection of the equipment. So disinfection by circulating hot water at 90 to 95 degrees centigrade for 10 to 15 minutes after the returning temperature is at least 85 degree centigrade. So here a lot of people make mistake, like they are sending the water at a correct temperature, but listen, when we are sending water from one side, like from our balance tank, it depends on the process and how long it is. It must reach at each and every component of the processing line, yeah, like maybe tank or somewhere everywhere, uh, and then it should return at least 85 degrees centigrade temperature. Otherwise, it will get cold. It will get cooled in between, and the cleaning, the sanitation won't be achieved properly because the temperature is already decreased. So this is the
Sir, can you hear me?
yeah. What happened?
Sir, yeah.
Something about membrane cleaning as well because this is another important part in dairy and food industry. So membrane cleaning is more sophisticated, more critical as compared to other equipment cleaning because it is mostly governed by the type of membrane material which we are using. And there, my suggestion is only very simple, like strictly follow the manufacturer instructions. The reason uh, different membrane material have different properties. So a material can withstand only 35 degrees centigrade temperature, very low pH range or a specific pH range, while others can withstand with all the temperature, other pH range. So if you are deviating from the parameters in terms of pressure, temperature, and pH range, which
Sir,
has been
sorry to
given.
interrupt you. Your screen is not visible, sir. Can you reshare your presentation?
Uh, Check it out.
No, sir, nothing is visible.
Nothing is visible.
Yes, sir.
Now, just a second. Is it
Yeah, sir.
visible?
Yeah. Yes, sir. Yes, sir.
Okay.
Yes, sir.
So I was telling that cleaning of membrane is more critical. So please strictly follow the instruction of the manufacturer. Very less scope for the deviation, and based on the membrane resistance, cleaning chemicals are selected. And enzyme cleaning is an efficient tool in absence of the harsh cleaning solutions. Now, coming to the sanitation. So sanitation was originated from the word sanitas, having the meaning health, but the same word has another meaning, that is the creation and maintenance of the hygienic and healthful conditions. So it is considered a joint venture of the by sanitation. So product can get contaminated with the new and well-designed plants if proper sanitary practices are not adopted. So its main function is to prevent the major food waste safety incident to happen in future. Uh, in this slide, you can see different examples are there. Like this is the agent, this is the bacterial species which was responsible. The food was ice cream, and that much population was got ill at a time. Basically, what happened? There was a tanker which carried the egg solution, and it was not properly cleaned and sanitized. And then this bacteria get entered into the tanker, and the same tanker was filled with the these incidents. So both steam, hot water, and chemical sanitizers, and then steam sanitizer on the equipment surface for the desired time duration. As per in chemical, chlorine, iodine, or sanitation, sanitizing solution of desired concentration is kept in the contact of the equipment surface for 2 to 5 minutes with slight back pressure in the pipelines, so that there will be a correct contact of the solution and equipment, and also be applied as fogging, spraying, and with the help of brushes. So here you can see different characteristics of these sanitizers. These are the sanitizers, and you can see the germicidal efficiency, yeast destruction, mold destruction, self strength, stability, stock usage, speed, penetration, film forming. So you can make it between all of them. Here also like ease of measurement, ease of use, odor, taste, effect on skin, acid is moderate, and quaternary ammonia compound size moderate. So these are the chemical sanitizer. Like we could have them as a chlorine, all food contact surfaces, spray, CIP, fogging, iodine, all food contact surfaces approach as a handle. Pancreatic acid and QAC, these can also be used in different environment for drains and tiles. Okay. These are some general summary of the activities of the commonly found disinfectant in the dairy and food industry. So, which is applicable for what very active or slightly active or not active. Likewise, we can use different uh, sanitizers. Now, water attributes important to cleaning and disinfection. So, sanitary quality, water used in the food plant sanitation must be potable. It means it should be at least fit for the human consumption. Microbiological standards, main microbial specification for water, measured in coliforming unit CFU, total bacterial count should be less than 100. Coliform count should be absent in 100 ml, and E. coli should be absent in 100 ml. Taste and color. So this water should be of good quality because we are using it for the cleaning purpose. And if our water is not good, this cannot lead to better cleaning and sanitation. Okay. So this is the TDS and the dissolved gases and even pH. This should ideally be between 6.5 to 7.5. Below pH 6.5, corrosion problems will occur, and the maximum alkaline pH allowed is 10. It's the alkalinity.
Sir,
Can
can
you
you
let me?
read?
Yeah. Can you see my slides, please?
Yes, sir. Yes, sir.
Okay. So main objective of daily this is to like maintain uh, the health of the consumer, like the face of the faith of the consumer. So that is achieved through consistent maintenance of the quality, and it is affected by design and layout of the dairy building, material and construction of the equipment, personal water quality, cleaning practices, and the laboratory control. So based on hardness, water three sanitary standards should be used to overcome the specific cleaning problems, like you can see in these figures. And personal hygiene is mandatory, which can be maintained by proper training, education, and written instructions. Everything could be at place, but the